This is X3, practice exam number 3, and I'll go through the first 3 questions that are related to like basic probability and the conditional probability table thing. So the first one is just algebra definition. So based on the definition of A given B, we write A given B as just AB divided by B, and that's 6 times the value of B given A, which is AB given A. So immediately we can see that we can cancel out the AB, and we can just write probability of A is 6 times probability of B. Okay, now we know A, 0.4, then B is just 0.4 divided by 6. So that's the answer. Again, it's just applying formulas. And the next question is about conditional probability table, or CPT, if we're talking about the Bayesian network. And the question is, if we want to store the information about B given A, how many numbers do we need? So we need to know the relationship between some of these. So in particular, if we want to compute probability of B is, say, 4, given A is fixed 1, the question is, how does this relate to the other probabilities? So here, given A is 1, there are only 4 possible values of B, so they should sum up to 1. So that means B is 1, given A is 1, subtract probability of B is 2, given A is 1, subtract probability of B is 3, given A is 1. So basically it means if you store these 3 in the table, then we don't need the last one. The last one can be computed based on these 3. So, and it should be the same for A is 2, A is 3, and so on. So it seems we need to store 3 probabilities for each of the 6. So the total is 18. But you may want to ask the question, can we compute this as something like probability of B is 4, like 1 minus B is 4 given A is 1, 2, 3, 4, 5, and 6, sum of these? And the answer is no. So the conditional probability just means given A is 1, B has a distribution. Given A is 2, B has a different distribution. So they are completely not related. So we cannot say that they sum up to 1 like in this way. Given A is different, A is having the different values, they may not sum up to 1. So that is actually false. So we cannot save even more by computing like the A is 1 based on A is 2, 3, 4, 5, 6. So that's why 18 here is the least number of probabilities we need to store. And question 3 is basically just the opposite of what we just did. You have the drawing probability table, so it's kind of a huge table that stores all the probability combinations, like x1 is 1, x2 is 1, 2, 3, 4, 5, x3 is 1, 2, 3, 4, 5, and so on. So you have a large table. There are 6 random variables, each one with 4 possibilities, so it's kind of 4 to the power 6 number of entries in the table. So if you compare this with just storing the conditional probability, it really saves a lot of numbers to store. But, well, it's not related to this question. This question is asking how to compute x1 is 4 based on the drawing probability. So you have x is 4, and you have x2 is 1, 2, 3, 4. You have x3 is 1, 2, 3, 4, and so on. So you have 6 of these. All of them can be 1, 2, 3, 4. And you cannot compute one of these based on the other ones because you don't know the sum. So you actually need to access all of these entries. So 4, 1, 1, 1, 4, 1, 2, 1, and so on. So basically you need all of these combinations. You need to access all of these numbers in the join probability table in order to figure out this one probability of x1 being 4. So we need to compute how many of these. There are 4 of these, and there are 4 of these, and so on. So in total, there are 5, say, other variables other than x1. So it's 4 to the power 5.